I hope you're having great day today, and thank you for logging to my YouTube channel 365 Pixels. My name is Amir Saeed, and with over 15 years of experience in different companies as a full stack developer, I've seen that database contribute a lot in business success. In this series, we will deep dive into PostgreSQL, which is one of the database and which it is very much famous nowadays, and we will explore its architecture, optimization technique, and then we will build a real world e-commerce application or database at the end of this video. Whether you are a beginner looking to build your first database or an experienced developer to fine-tune your recent knowledge, then this series is for you. Join me and unlock the true potential of this PostgreSQL, and let us make you ready to power the future of your application. So let's get on with it. To install the PostgreSQL, we need to download from the website, which is postgresql.org. If you search in Google Chrome, download Postgres, it will give you this website. So when you click it, takes you to the main download page where you have option based on your operating system. Mine is MacBook, but your can be Windows or Linux or Solaris. Okay, when you click it, it will take you to the next page, and here is the actual link. You click it and it will give you another option to download which version you want to download. I will download the latest one, which is 17.2, and is for MacBook. When you click it, it will start downloading it. Next thing is, when you download the DMG file in the download folder, double click it, you will land on this screen. Double click it and it will install the installations. This is the screen you will see. Next, and this is your directory, and by default select everything, because we're gonna need this pgadmin. This is user interface, graphical user interface to view the data, so we're gonna need this one. Command line tools as well. Leave as it is. Then next, and the password, you can set any password which should be memorable, and also it should be easy to remember. Okay, so I'm gonna use the simplified version because it's a test, so it's not big deal for me. But and also leave the port 5432 as it is. Okay, thank you. Default locale, no need to change. Next and next, and it will start installation. So please after installation, when you finish the installation, then please go ahead and through menu open this pgadmin. When you will open it, you will see this first screen. So here we need to create the server. Okay, so first click here, and the server for us is e-commerce store. Okay, so e database, and the connection is localhost, and this is the password is must. This is same password when you install the pgadmin and PostgreSQL server. So and click save. So again save the password, and that's it. So this is the first screen you are gonna see it. These are the default databases, everything. So we don't have schemas, anything yet. Okay, here if you see our table database, everything will be inside here. Okay, so there is no table yet. So the next thing is we are going to create the table. That's the next step. Okay, then we'll start learning the PostgreSQL database and SQL queries. Okay, so the next step is we are going to start creating the table, inserting the value inside and fetching the data, add some columns, update some values, alter column, drop column, and delete it and drop the table. Okay, so these are the CRUD operations we are going to do it. The first thing is to start with the create table. So expand this schema. You go from the actual database servers, PostgreSQL server, and databases schema, and here you have two databases. Okay, so one is e-commerce, the other one is PostgreSQL default one. Okay, so we are going to use our own database, expand it, and here you will see schemas, expand again, and you will see the tables. There is no table at the moment. Okay, so this top query tool, you click this one, it will give you the actual query where you can write the queries and you can execute it. Okay, so first table we are going to create is this one, create table employee. Okay, so our first table is employee table. Here we need to speak, we need to concentrate the data types. Okay, so data types are the types which your fields can have, like attributes of. Okay, so in this case, like the field data type is either string, varchar, or number, numerical digits or something. Okay, so the first step we're gonna do is to create the table. So in our database, by default, when you log in, you will see there will be two tables, databases. One is e-commerce database, the other one is Postgres default one. We are going to use our own e-commerce database. When you expand it, there is schema and public, and then the tables. There is no table at the moment. So click on this query tool. When you click it, it will open the query tool. Queries are where you can write simple queries. So in this our case, we are going to write this create table query first. So the first step is to create the table. Okay, so simple table, we are going to create employee table, and employee has attributes. So employee has ID, employee has name, email, phone number, when it was hired, its job title, which department it belongs to, and the current salary, any manager ID sort of things. Okay, so these are the employee attributes, or we would say in database language, these are the fields. Okay, so employee table has fields, and these fields has some sort of database or data types. So you can see that these are the data types in this create statement. Okay, so the data types can be varchar, it can be auto ID, it can be decimal, it can be integer. So normal data types we can use here. Okay, so varchar or varchar 50 means it has 50 characters in that one. Okay, maximum 50 characters it can accommodate, not more than that. Email, the max length of email can be 100. Phone numbers maximum 15 characters, and the normal is hire date is date, and then job title maximum 50 characters. Okay, and if you can create the same thing with your uh, UI table. Okay, UI, instead of writing the statement. Okay? And here you can add these columns. Okay, so you can add the column employee ID, and then you can see that data type. It has so many different data types, but most common data types we use is like big int, integers, bit, or boolean, uh, varchar, string, decimal, integer, that sort of stuff. Okay, so these are the most common, but it has flexibility to store different bytes and characters and circles, and it is quite huge data types it supports. But we are going to use through query instead of graphical interface, so we're not going to use it. So this is the first employee table we are going to use, and this is create command, and executes script. You can press F5 or you can click this button, and it has created the actual table. If you see, nothing, but you have to refresh it and you will see the table here. Okay, so this table has columns, clearly everything. So the table is created and through this command, create table and employee, and then brackets. Inside brackets, each and every field is comma separated, and each and every field has its data type. We can use ID as integer, but serial is the unique things which is auto incremental, as it says here. Okay, in the comment section, so it's automatically incremental. Why I need it? Because each and every table have its ID. It's gonna auto increment means the 1 2 3 4 onwards, like it has like auto generated IDs. Okay, so this is the column we gonna need in most of the tables where we need auto ID, incremental ID. In this case we have employee ID, which will be like start with 1 2 3 4 5 onwards. Okay, so this is first statement, create. Now the next statement is we are going to insert the database in it. Okay, after creating our database data table, this employee table, so the next thing is we are going to insert the values into the table. Okay, so these are the 10 employees we are going to insert into this table, and the statement is insert into the actual table name, then these all columns which are mandatory, then and values, and then you can insert like this. Okay, you can insert one by one, or you can insert all 10 of them together. Okay, so I'm going to insert 10 of them together. It can be 100 200 300. It Postgres provides quite flexibility to insert large data set into the table. So this is the statement you can use. Okay, let's run it. So now you have all 10 records in the table. One thing is to, you can write the query here, you can open another one, and The simple select command is this one. Okay, simple command, which is select command. Select asterisk from employee. So this is employee table. Sometime you will see it's public dot employee. Okay, which is like all these tables belongs to public. Public is one schema. Okay, so all these employee or tables belongs to public one. Okay, some tables, why they are, because it's a security. All tables are by default public, but some tables you can create some schemas and allocate to some employees, so those employees only will be able to see or run the queries, and they will be able to see those tables only. Okay, so it's basically security thingy, but that's the later issue. But this one is the select command, which is the simplest command you run, and here you can see the complete data which you have in your tables. Okay, so everything is there: first name, last name, email, phone number, hire date, and job title, department, salary, manager ID. Okay, you can set the hire date or date format when you creating the actual table. It can be British, DD, MM, YY, or any US data format. Okay, so it's up to you, like where which format you want basically. Okay, so this is at this point we learned three statements. One was create table, where we created the table, employee table, with actual fields, their data types, and then the next one was we insert the data into the data table. 10 records we inserted into the employee table. Then the next one was a select statement, where we select asterisk from employee, and the next statement we can use, there is requirements, for example change at later stage. If you want to add some extra fields into the table, like if company says that, or if there are requirements, then you need to add some extra fields. So then there, the next statement is alter table and employee, the actual table name, add, and what column you want to add. In this case you can see that there is no social security or national insurance number here. Okay, so you can say that SSN, social security number, or any things, or even you can write social security. Okay, but I will write it short. Okay, SSN and social security, and data type could be varchar 20. Okay, so this is the statement, and let's see, run it. It's successful. Now select this statement, let's run it again, and here at the end you can see that it added SSN to the actual table. Okay, so this is how you add extra fields by using this statement: alter table, employee, SSN, and then data type. You can add multiple by writing comma and more fields here. Okay, so more fields with their data types, and run that statement and it will work. Okay, so you can add either one column or multiple columns simultaneously. Okay, the next statement we are going to focus is update. How we are going to update the database data table. Okay, so there are requirements sometime that we need to change the table information at some point, and this is normal practice in any database. Okay, so keep changing the values or information. So this CRUD information or CRUD operations occurs frequently every day in normal life. So we are going to focus the same. So the statement is update employee, and we need to set, let's say here we are going to change the manager's ID. So all those where there is null, we can change information, to, for example, 0. Okay, there is no manager. Instead of null, might be we can allocate number 10, manager ID 10, which is normal, might be some XYZ department. Okay, so we are set manager ID is equal to 10, and this is the command we need to say where clause. Okay, so where manager ID is null. Okay, so before running this command, let's focus on this select from employee. If you run this one, you get the same thing, and here also you can write this where clause. Where is the condition where you can use like if you want to filter the data into small portions or some small subsets. Okay, so you use where clause. And how can it use like where, and then the next will be column name. Okay, so where first name is equal to John. Okay, yes. So if you run this one, my bad. So you see it has record, and it found the John is the only person who's met this requirement. Okay, so we found only John. The similar is you can use like operator. Okay, where first name like and John, it still will give you same, but if you're not sure, you want to get all those person which starts with J but with percentage. Okay, so all persons whose name starts with J, you can select or write like this percentage column and like and where. Okay, so it will be like this. So it found two persons whose name started with J. Okay, so John and Jan are the person. So similar is you can compare with date is greater than 2020, or any person whose department is engineering department. Okay, so you can write that all those persons whose department is engineering. Okay, so it will fetch only those whose department is engineering. Okay, so it found John, David and Grace. And also you can write greater than or less than. So greater than in SQL is like less than, and then greater than is like this. Okay, so you can use this with salary. If salary is greater than 40,000. Okay, all those personals whose salary is more than 40,000, so it got all these people. Okay, 10 of them, but we can write 60 or 70 might be, and run it again, and you see that it has only 7 people. So all these 7 people, their salary is more than 60. So where clause is most commonly used in select statement. Okay, so you will see in variable conditions, and also you can use and normal and whose department is engineering. Okay, so it will find all those employees whose salary is more than 6,000 and whose department is engineering. It will get only 3 people's whose salary is more than 60,000 and their department is engineering. You can keep adding more conditions if you want to. There is no limit to filter the data. Okay, so this is where you use the where clause. Similar, that where clause you can use here as well. Okay, same condition applies in update. So you can update here. For update command, we can run where clause with like is operator. Okay, so it will be, instead of equal sign, we can use is and then the actual condition itself. In this case, it's is null because the value we have here for these 4 columns is null. So we are going to update all those employees whose manager is ID is null. Okay, so it's gonna insert 10 by default. Let's run it and run it again. Now you see that all those employees whose manager ID was null, we added by default 10. And similar, we could have used equal sign is equal to null, and it will work. We can add multiple conditions with and, like and or. Okay, so both operators we can use for multiple conditions, like if where ID, like in this case, like let's say employee ID is 3 and we want to change the manager's ID to something, might be 3 or 4. Okay, and it works like this. Okay, yeah, so manager ID is changed to 4 for Bob. And similar, and we can use like all those IDs which are might be greater than 2, and we can use and condition and operator, and whose salary is might be greater than 500 something. Okay, and salary is greater than 60,000. Okay, so what it's gonna do is gonna change all those employees, their managers, to 4 whose salary is more than 6,000 and employee ID is more than 2. Okay, so these are 2 conditions. If when it's gonna met, then it will change this value. Okay, let's run it, and here it run. You run it again and you will see it has changed all those employees whose salary is more than 60,000 and employer ID is more than 2. So all these employees basically. Okay, all these employees whose ID is more than 2 or greater than 2 and salary is more than 60,000, it has changed to 4. So this is how you can use update command to with the combination of where clause and also and or, and we can use or here as well. Okay, either one of them. So it will be either this condition true or this condition true, okay, we can use or operator or we can use and operator. Okay, so it's both is valid. So update and table name, then set, and also here you can uh, um, update one column or two column or three columns simultaneously, okay, with the comma separator. Okay, so it will be if you set, like, you want to change the phone numbers or some job titles or something. Okay, like here job underscore title is equal to, you want to change all those employees whose salary is 6,000 and they their manager is 4, so their job title you want to change to something else, or you want to change even let's say department. Okay, you want to change their department to um, something might be design. Okay, so if you run this command and check it, so you see all those implies their manager is changed as well as their department is changed. So with this combination you can add more columns, the columns which you want to change, and as well as you can use where clause with the combination of and or operator. Now next command is alter columns. So sometime we have requirements that initially the specification we applied during table creation, we set some particular fields uh, length like 25, let's say. Okay, and later on we identified that the length is not sufficient enough. Okay, so we want to extend it or reduce it. Okay, so for example, if you set the column length might be 25 or might be 100, you want to increase it or decrease it based on your new requirements, then the command we will use is alter column. So it has two possible scenarios. One is to change the existing column to the same data type. For example, if it's var char or integer, change to the same var char but just change the length. Okay, or the other thing is to change the data types. For example, if you set initially as a string, then initially later on you recognize that it must be integer, so you can change the data type from string to integer or string to string but just change the length. So two possible scenarios. Let's say let's check. Okay, so the actual command would be like this: alter table, the actual table name, alter column, and let's say in this case we want to change the phone number. Initially we had this phone number like this, and might be later on we identify that 15 length is not sufficient enough. Okay, we want to extend to might be 20. Okay, so let's say like we can change to varchar 20. Okay, so initially it was set to 15, now we want to change to 20 length and run it. Now if we run it again, and you can see that is 20 now. Okay, so the length is extended to 20. That's one scenario. The other one is like we their SSN number, for example, there is no value yet and its value is 20 here. Okay, the actual character length is 20, and we identify that SSN, let's say it can be integer only. Okay, or decimals. Okay, so we can change the data types for this particular field to integer rather than the actual characters. Okay, and the similar, the statement will be ssn. Okay, so the column name is ssn and the type is integer. So we change the, so the command is using, also we gonna use this using ssn and integer. Okay, so I just forgot to mention this one, and you run it. Okay, so actual column, and you are going to change the new um, uh, data type. Okay, so if you run again, and it's integer now. Okay, so value is integer, so you can revert it back to again varchar to, for example, 20 and var variable characters 20. Okay, and run it again, and so it's back to 20 again, 20 variable characters. Okay, alphabetical, so alphanumerical characters 20 varchar. So this is how you can change the data types of columns based on your requirements. Like if you initially set some wrong data types or less length, then you can extend it or you can decrease the length by using alter table and then the actual command, then alter column and the column name, type and the new type. It can be existing type but with the new length. Okay, or it can be a different data type like integer and integer here. So now next requirement, like let's say you added some column in the database and later on realize or the requirements change and you don't need that column anymore. Okay, so you can, one thing is drop the column through interface like here. You can right click and delete it. Okay, so that's one way to do it. The other one is with the command base. So with the command base you can drop the column, and let's say we are going to add one column first. Okay, the new column, we are not going to delete the existing one. Let's say the new column we have is password. So you added password some point in this table, and the password is, you run this one, and this is the new column right to the end. Whenever you add any new column with the statement, it adds right to the end. Okay, so it has 20 characters and this is the new column password. And let's say right from the beginning it was there in this table, and it's no use so far and you want to drop it. So to drop, simply this is the command, you can write it, and so alter table imply and drop, then column and column name. Okay, so when you run this one, it will drop or it will delete this whole column at all. And one thing to consider is when you drop this, there is no recovering back. Okay, so be cautious and be careful, and thoroughly analyze first whether you really need to drop this or you can keep as it is in the database as long as it is not creating any problem at all. You can keep it if it has so much data. But if you really want to delete it, this is the statement. So alter table, table name, and drop column and the column actual name. Okay. Sometimes there are redundant records in the database, and or there is requirement that we need to get rid of certain data, legacy data which is not required, or some certain records which we don't need in the database, or there are clutter data sitting around. So to previously we deleted the actual column, truncated the column. Okay, so this time we are going to delete the actual data itself. Okay, so to delete the data or some particular records or 1 or 2 or 100 or 1000, this is the command: delete from employee where and actual column name. Like in this case, employee ID is, let's say we want to delete 36 Emily. Okay, so 36, when you run it again, so 36 is gone. Okay, Emily is gone. So this is one way to do it. Always like use a bit cautious and care when you delete the records, because slight small changes makes much more difference, and it can mess up all data. Instead of equal, if you write like this, greater than 36, so it will delete all those employees whose ID is more than 36. Like might be there are 100, 200, 300 employees. Okay, so all will get deleted. So be careful with the deletion. This always be cautious with deletion. The another way is to, like, let's say we have marketing department. Sorry, department is marketing, and it will not find, because here marketing we have is, I think, capital, so it is case sensitive. One thing to point out, that Postgres data is case sensitive. Okay, and if you use small letters, it hasn't found anything, but with the capital M it has found 5 records. Okay, so somehow, like, if the company outsource its marketing department and you want to delete marketing department from the database, so this is one way to do it. Again, instead of hard-coded ID, so all, like, you can use the conditions like this one. Okay, so it can be done based on employee where department is equal to, let's say, marketing small. Okay, and if you run it, no record deleted, 0, because the case sensitivity, Postgres is case sensitive. Okay, and if you run again, still data is still there. Okay, so this is one another thing, Postgres is case sensitive. You do marketing here, before deletion it will delete 5, but if you want to delete only those whose employee ID is more than, let's say, 60. Okay, and you can use and employee ID is more than 60, so it will delete only these two. Okay, or you can use or command, or with the combination of others, like if salary is more than 50,000 or 60,000, then, like, you can use multiple conditions here, what I'm trying to say is. Okay, so let's run this one. So it has deleted only two those records here. Okay, so this is one way to do it. Another one is if you don't use this command at all. Okay, simple, use this command, which is dangerous one in a way. Like if you run this command, it will delete all records in the database complete. Like we have let's check, we have like 35 rows. Okay, so all those 35 rows will get deleted. See here, 35 rows get deleted. You run it again, select command, nothing is there. Okay, so this is another way to delete complete, like empty the table, which is not recommended, but you should know. Let's insert again those records, and if you, we have all 40 records back. Another one is to do it another command. Okay, this delete from employee, it's going to delete all records, and the same thing is truncate table and table name. Okay, so you can truncate the whole. The next thing is if you want to drop the table completely. Okay, if for some reason the table is temporary table, or you want to delete the whole table with this data together. Okay, which is not recommended, but some, or might be there is some redundant tables lying around in the database, and you want to refactor it, you want to clear the mess or clutter. Okay, so the statement is simple statement, and is drop table and the actual table name. Okay, drop table table name, and when you run this one, nothing will be there. Okay, so you can't find any. If you refresh this, there is no table left, so table is gone. So this is the last statement. So we've been through the CRUD operations. First, it was the first phase of the actual tutorial. So we created the table, inserted the data, we fetched the data and add columns, then we updated some values inside the column, we altered the column, dropped the column, and also deleted the column. So this is the actual CRUD operations I wanted to show you. So how basically simple table works, everything. Okay, so the next one will be, we will go in detail every single operations, and where we can use orders, limits, min, max, constants, that sort of stuff. Okay, so the next phase we're gonna do in detail each and every aspects of this database, so to make more sense, and also go through a little bit more complex scenarios where you have as we have deleted the employee table now, nothing is in there in the database. So I think this is the time now discuss with the actual primary key and primary and foreign key. Okay, so primary key is basically unique identifier in each row. So each and every tables, there might be one, or there's slight chance that there is two primary key. Okay, which is called composite key, but each and every table will have at least, not necessarily, but there will be always uh, one primary key which will uniquely identify that particular row of that column. Okay, like in our previous example, the employee ID was the primary key, so each and every employee have its own unique employee ID. Okay, one is might be the actual batch number or something, the other one is the database in given ID, like auto incremental style. Okay, 1 2 3 4 5, so these are the primary keys. So this is uniquely identifier, and each and every table will have only one particular key assigned to that row. Okay, let's change and we'll it, and also primary key. Then there is the concept of foreign key. The foreign key is like parent child concept. The employee is like the child of department. Okay, so department is parent. In one particular company there will be some departments, 1 2 3 4 departments. Okay, sales, marketing, IT, HR, so these are the departments. So each and every employee will be part of those departments. Either few people will be HR related, the other one will be some IT department related guys, and few will be the marketing, and some will be the sales guys. So each and every employee is the child of some particular departments. Okay, so to start with, we are going to create the department first because it's parent, so always start with the parents first. Okay, now this is the actual statement, and the statement is like this one. Okay, let me go through one by one. So we are going to create the actual department, and if it's not exist, if it exists, then just don't run it. Okay, and here we are assigning the department to this Postgres user. Okay, so the actual user is Postgres user. This is not necessary at this point. When we're gonna run it, it will automatically associate this table, department table, to Postgres, but it's better to assign the role. So basically the owner of this department table will be the Postgres. Okay, and we have department, and serial is the actual primary key, so it will be serial number 1 2 3 4 automatically generated, auto generated. The department name is 100, and another thing is not null. Okay, any column you don't want to be null, and it always should be there, because the department will never be ever be null. Okay, company must have some sort of department. So you have not null, you can define the constants, it called constants. Okay, and manager ID of course is integer. Location can be anywhere. Budget, the actual budget of the department, and this is the constant. Okay, the constant is the unique name, unique, and then department. So what is that, you can not write this one, or you can write it, it's up to you, depends on the requirements. If you want to force the user never ever enter the department's value null, so this is how you write the constant. Okay, so the constant can be unique, and what the actual column name, so it can be with the comma separated. Okay, in this case we are forcing the users to enter the department name always, never leaves empty blank, and the unique constant's name can be anything a b c, or you can write underscore xxx. Okay, it doesn't matter, any unique constants you can apply on this table, and when you run it, refresh this, you will see the department table is there. Okay, now the next thing is we can insert those values. So we have 10 departments. Okay, each and every department and the yearly budget of each and every department. Okay, and this is their location. The different departments can be in same location or different location, doesn't matter. And each and every department and its name, nothing is empty, always there will be department. And each and every department has manager ID. Okay, this manager, there can be another manager table. Okay, primary foreign key concept, and that ID can be the part of that manager table. Okay, so or employee table or something. Okay, but this is the way like we can define the constants. Primary key is always, you see here, primary key is constant. So this is to tell the actual table that this column is primary key. And we have not null, and because to force that not null, we introduce the constant there. Okay, this is department. Now we change the actual employee table. Okay, so employee table is changed, and if you see that excuse me, drop the table if it already exists. In our case it does not, so we don't need this one. But it's better to, when you generate the script, it's better to have this in case the table already exists. Drop it first, then recreate it. Sam serial primary key, first name cannot be null, last name cannot be null, and also email cannot be null, phone can be null, hire date cannot be null. Okay, and this is the main things. So integer not null, department ID. So department ID is the actual foreign key to the department, and how we gonna bind it here with the constant, I'll show you. Salary, another constants, another way to add the constants, like, so this is check, salary is always 10,000. So no employee we are going to add whose salary is less than 10,000. Okay, all employee, the policy, this is like, let's say in company there is no policy to hire any employee less than $10,000. Okay, or pound. And so this is the constants you can add. So if somebody is going to add some employees data, they can't add 0 or 5,000 or 2,000. Always there will be more than 10,000 salary. Okay, manager ID and SSN, and this is the important bit which basically creates the primary and foreign key relationship, master and child relationship. Okay, so this employee is the child of the actual department table. So constant, any constant name, anything is not necessarily, but it's better to use FK, foreign key. Okay, so this is the industry wide commonly used way to write the foreign key name. So foreign key and then the actual table's name, whose you are going to connect this table. Okay, so constant name, foreign key, what sort of key you are going to bind together. Okay, so this department and the actual employee table is binded together via department ID. Okay, so this is department ID, and reference is public department and the department ID. Okay, here there is slight chance that instead of this department ID you can name only id. Okay, just imagine that this is only id, so you don't need this department id, it will be like id. Okay, so your local this department id is connected to the id of this department id if it was id. Okay, but in our case we have used the department id full name, full id name. So whatever the column name here, you have to use the same 100% column name. Okay, so this our column name is connected to the foreign key of this department id. Okay, and so in this way, when you will try to add any records in the employee, and if this department does not exist, it will give you error. Like for example, departments there are 1 to 10. Okay, if you try to add number 11 or 12 in the employee table, it will give you error that foreign key does not exist. Okay, this is how you force the user that each and every user or employee you add belongs to some definite and correct departments. Okay, so basically you will end up less redundant or cluttered data. So the idea of these constants is primary, foreign key, everything is to have normalize, less redundant, clear, clean data. Okay, and if you run this one, okay, because it does not exist. Now let's insert, and you will see the department, and also imply table. Okay, does not exist. So let's add. So we got 20 employees and one department. And one thing you can see is all these values before it was marketing and sales department, IT department. Now they are IDs because we have primary foreign key. Okay, and primary foreign key is helpful, but we will discuss later on. And now we can start with the operators this time. Okay, so let's say so there are few operators. Let's close this. So the first lesson we are going to use is we are talking about operators. Okay, so operators are equal sign, less than, greater than. These are the common operators used in where class in SQL, PostgreSQL or any kind of SQL. Okay, less than, greater than, or less than equal to, greater than equal to, not equal to, or we can use not equal to. Both are same thing. Okay, and they both are same statement. And then like operator, and we have used previously or operator. In we are going to use this tutorial between is null or not. Okay, so these are the operators we will run in this learn in this tutorial. We have employee. Okay, and where class we are going to use, and we are going to search, let's say, job title. Okay, where job title is equal to business analyst. Okay, so it gave me James Anderson, whose job title is business analyst. Okay, so this is how you use equal sign, equality, or where employee ID is equal to 9, you can use that one, or first name, or where first name is equal to James. Okay, you can use that. First name is equal to James. It has found. And if you write small James, you see that it hasn't found anything because it's case sensitive. Okay, one thing. And this is equality sign. Okay? The next one is less than sign. So less than we have used previously, where salary is less than 70,000. Okay? So now if we run this one, so all those employees whose salary is less than 70,000 is going to return us 11 employees. Okay, so less than, so this is now greater than is the same thing, all those employees whose salary is more than 70,000. So these are the employees whose 8 employees whose salary is more than 70,000. Okay, so you can use this one, and then less than equal to, less than we had 70,000, and let's say we want to run 65,000. Okay, so 65,000, oh sorry, so 65,000 is going to return 8 employees, but if we want equal, so it has returned us 9 employees. Okay, what has happened is it has included all those whose less than 65,000 salary, and also one employee whose salary was 65. Okay, so less than and equal to, so these are the conditions. So normal 9, and if we get rid of this equality sign, so 8. So one employee is the basically edge case. Okay, where you have one employee whose salary is just 65,000, so that's also included in this one. So less than or equal to, the similar goes to greater than, and if you do greater than, we have 11 employees whose salary is greater than 65, like $65,001 sort of things. Okay, but if you want to include the same person and equality sign, so it will be like 12 people. Okay, so 12 people are part of this whole record. So 12 people are returned through this statement. So equality is basically includes anything which is equal or anything greater than. Okay, so and if you have some employee whose so these 5 people are returned whose department is 1. If you don't want to include or search that department 1, and you want to return all those employees whose department is not 1. Okay, not. So simply you write like this. So it will return all the rest of the employees, 15 of them, whose department is 1, not 1. Okay, so they are not part of that particular department. Similar, not you can use another command like and salary does not equal to $65,000. Okay, oh, my bad, typo, mistake. So it has eliminated the person whose salary was 65,000. Okay, so this is the way you can write this command together, or you have any other condition, then you can write like this one, and using like or condition or something like, okay, or okay, so it will give you the specific option with or if you want anything, either this is true or something else. Okay, so you can use or condition with these brackets as well. Okay, so does not, similar you can use not equal to, is same thing, does not equal to, it will give you same results. Okay, same results. So either you can use like this, does not equal to or not equal to, they both are same. We have used one time like operator. So like is when you are not sure but you want to search something, like if you are searching something, first name, like all those employees whose name starts with B. Okay, oh, sorry, my mistake, it hasn't found anybody. Okay, but if you try capital one, so Bob and Benjamin is, it has found. Okay, so Bob and Benjamin. So like operator you can use complete or partial information. Okay, if you are not sure something, then you can use like operator, like department is more than 4, or anything partial information. Okay, if you are not completely sure, then you can use the like operator. And the other one is I like. And you have used that one. We have used R as well, in. Okay, so where, so let's say like we have used already like and R conditions. Okay, let's check in condition, where department id in either two. Okay, So when you have multiple options available, then you use in operators. So like if you want to batch the list of values, right? For example, if car is in Mercedes, Ford, or Volvo, or department is in 1 2 or 1 5, okay, or job title is in software engineering or HR associate. So in is basically when you want to um, match the column value with any of the values in the list, okay. So you have list of the values. For example, in this case you have 1 and 2. So department will see this field that 1 and 2 exist in the table, and it will bring all those whose department is 1 or 2, okay. Sam, you can write like a job title in, and the job title is in software engineering, and might be HR associate something. Let's check. So it has you can see that I wanted to show that double quotes doesn't work, it gives error. So it has found those employees whose job title is either software engineer or HR associate, okay. So these are the 3 employees it get. So in, and if you are not sure like the exact, and you want to search all those records between 2 dates or between 2 salaries sort of things, okay, or then you can use between, okay, where like salary between 40,000 and 50,000, okay. It has just get those employees whose salary is in between, okay. So between, you use the between word and then condition and word and this one, okay. So this is how it works, like between means 2 dates. If you have particular dates here, for example, higher date in between, higher date is in between 21st to 29, okay, 2 years or 2 particular dates, then you can write here higher date between first date and second date, and it will get you the all the data in between those dates, okay. So this is basically in between, okay. Anything which satisfies this condition, it will give you the results. And the last, not the least, is where salary is not or not null, or nothing is null here. Okay. So you are getting all those records. In some cases might be you have null values, so you want to see that all SSN numbers who are null, then you can write if SSN is null or something, okay. In our case we don't have null, but this is how you use it, where cell is not null or null. Okay, so this is one way to find. And the last one is not, we already showed. So next, let's discuss select command in a little bit more detail, because this is the most frequent used command in databases in PostgreSQL as well. And if you run always like this, it will give you the related column. The one way to do it, you can select the specific columns in select statement. You can generate your own select command as well. Here you see here, and it will have all those columns listed down here. Okay, if you run, and if you don't need employee ID or last name or something, you can get rid of. Okay, so for example, if you want to delete these columns and just only need some particular columns, you can get rid of this all. Okay, with comma brackets, comma. So this is how you can write the select command. And if you want like, let's say you have those all. Okay, and here you can see that everything is distinct, I think so, but there is one function, built-in function, like this, 20, so still 20 records. So if you want to get rid of repetitive columns, then you can use this distinct built-in function. Similar, it can be distinct static. Okay, if you don't want, there are slight chance that some tables it will have repetitive data and repetitive rows as well. Okay, there is slight chance that you want to get rid of, then this is the way you can do that. Okay, so distinct, and then even column name might be, for example, let's say department. Okay, let's say department ID. Okay, so you will be getting all these departments, and let's check another one. Job title, I would say they are repetitive somewhere. Let's check. I think job title. Okay, and there are 20 job titles. Okay. If you write distinct, they are 19 now. Okay, so one is gone. Anything you want to get rid of repetitive stuff, so distinct you can use for that particular column, or you can use the brackets as well. Okay, if you want to, it's the same thing. Okay, and if you have you want to count all those distinct, then there is count. If I can see there are 19s, but if you want to return in backend or somewhere, okay, so you can use the count built-in function. It will give you 19. Okay, so there is another one. So distinct, first you find the distinct all those job titles, and then you or counting them, how many are they. Okay, so distinct and count. Another thing is let's check, and this is the not alphabetically order. Okay, so another we have is order by. Okay, so order by is basically you want to order some table based on some particular conditions. Order by salaries, or you want to ascending descending orders, order by salary, order by department, or order by some dates, or order by like first name something. Okay, so it will give you this option order by. Okay, in this case you see here, so now is ordering ascending, and if you want to order by descending, then simply you add descending at the end, and it will give you descending order. So ascending is default, and then if you add the descending at the end, then it will be descending order. So alphabetically you can order by using order by. Okay, and also you can use where clause as well. Okay, so it can be joined together, where salary is greater than 70,000 and order by first name. So all those implies whose salary is 50,000 or 60,000, and order them in ascending or descending orders. Okay, so this is you can do that where salary is greater than 50,000, order by. Okay, so all those implies whose salary is 50 or might be 70,000, let's say, and descending by this one. If you want descending, then descending you can add there. Okay, next thing is the limit function. Okay, so if you have like 100, 200 or 100,000 records in a table, and you just want to see only some particular amount of data, you want to return it back from select statement, then limit is the function you can use as built-in function. And the way it is, like you use select from imply where limit, and because we have here total records 20. Okay, so let's see limit 5. Okay, and if you run it, it will give you only 5 records which satisfy the condition. Okay, and here you can write the where clause where salary is greater than like 65,000, and even if this statement might return 11 records, but when you limit it, it will always return those limited records. So basically you are going to put the limit on the number of records the query return. It is good in a way, like if some particular statement if you write in future, and there is slight chance that it can return tremendous amount of data, like a huge amount of data, and it can slow down the whole performance of the system. So sometimes it better to limit like 50 record, 100, 200, 500, 1000, 2000 records. Okay, so in this way, like at least system don't return like unseenable uh, records, like which can create problem about the performance and uh, the actual query itself. Okay, and system don't get freeze something. Okay, so better to use always limit function, and not always, but where you have not sure, you are not sure whether there will be some certain number of records will be returned by the query, and even like there are unlimited amount of data available, but you want to limit it in certain numbers. Okay, so use limit 5 and it will always return. Another thing you can do is like you can see that here uh, it returns 11, so you can use another built-in function offset and 5, right? So what it gonna do is it will offset these 5 records, okay, from David Miller, and it will start from this point onwards. Okay, so offset means like don't count the first 5 and start from the next one. Okay, and if you run it, you see like it started from 8 onwards 15, total 5 records, even though there was 6 remaining. Okay, so see total 11, and you're putting limit to it, but starting from just skipping those first 5 and start from the 6th one. Okay, which is this one, number 8, Sophia Wilson, and it will go to Daniel. Okay, so it will from Sophia to Daniel, these are the 5 records it will show because we have limit of 5. So this is how you can use limit and also offset if you want to. Okay, another thing is if you have some, for example, imply, the next function we are going to talk is min function. If for example this is script and you can generate, it will give you the all columns, everything. And now if you want to use like minimum, okay, so here is min salary. You want to find out what is the minimum salary, and of course there will be max as well. Okay, and if we use this one, it's not valid because why? We going to need the group by class. Okay, so that's another thing to discuss in future queries. But when you use this type of aggregated uh, functions, you always need group by class. Okay, so that's another things we are going to discuss in future, but let's start like simplified version. So this is some minimum salary we have is this one, 48,000, and the max salary we have is 90,000. Okay, so you can use min and max to find out the actual value, minimum value and maximum value inside this table. And here you see when you use max salary, it is showing you again like same max. So to rename that column, and if you want to make it some user friendly column name, you can use as and then column name as max value or something, or max value. Okay. So the column now is max value column. Okay. So you can every single column we have used here. If you okay, here you can rename this column as first name, okay, like this, and it is basically is here first name, and it automatically it converted into small letters rather than I used capital one intentionally to show you like the system Postgres always convert into small one. So you can use s and then the actual column name. It works with normal fields as well as this min max, all aggregate called aggregated functions. Okay, so these functions you can use as to make sense to the end user. Then similar goes to we have used before the count, okay, count or one thing is when we use asterisk, you know, number 20 like people are in this table. Okay, but you can use count and it will give you 20, so total sum basically. So count we can use like, and if we want like salary and still count, and it will give you 20 people's whose salary is in this table. But if you want to count how much salary the company is paying to their employee, okay, so each the total salary is this one 1.36 million. Okay, so this much salary the company is paying to their employees. Okay, so sum is total sum, basically sum of that particular column. Okay, and another one is average one, and another one is this average, like how much average salary of every one is getting in this company. Okay, so 68,000 is average salary. So average salary, the way formula works is the total like each and every salary divided by total sum. Okay, so average calculation is total like average, what average salary is getting paid to the employee. And you can see that it's giving you the quite long zero. Okay, so the best way is to use built-in function, and we can use numeric 10 and 2. So length it can be 10. As we have discussed earlier, the like operator. So let's discuss it a little bit more in detail. So like operator is always used with the where class, and let's say first name, we have first name, we have John and Jan, Alice, Bob. So let's find all those whose name starts with J. Okay, so this is one way to do it, J and percentage sign. So it means J with like multiple characters. Okay, so anything starts with J, Jane, James, John. Okay, so if you run this one, so this is three rows. It find three employee, John, James, and Jane. And similar, you can use like percentage sign here. Okay, if you want anything, any characters which is available in the middle. Okay, but when you click this one, nothing happens particularly. Why? Because as I discussed earlier, always like the Postgres is case sensitive. So J is starts with the first initial, but the rest of these letters, everything is in lower. They are not uppercase; they are lowercase. Okay. So if you write like J small case and try, then you see that Benjamin. Okay. So it finds that record which has Benjamin J in it. Okay, so J it has found, or even Ja, you can try that one. Okay, it still will find Benjamin. So you can use percentage in the beginning or at the end. So this is multiple to find multiple characters inside the some particular string, like in the beginning and in the end. And if you want to get rid of this case sensitivity in Postgres, so you can use I like. Okay, and here, so it will not consider the actual case sensitivity. It will consider both upper and lower cases. Okay, so in this case you see here J is in the beginning, J, and this J is in the middle. So it will get all those records regardless of whether they are uppercase or lowercase. It will find it. So instead of like, just use I like. Okay, and it will get the information you desire. And another thing is, if you're not sure that what is the exact word, but you have vaguely idea that it pronounced like this. Okay, then like it starts with B and you have no idea whether it's A or E or something. Okay, and then N, and it is like 6 letters. Okay, you try to find it, you'll find nothing. But if you do another one, it finds this one. What this represents is single character. Okay, so percentage sign was multiple occurrence or multiple characters it can find based on that. But underscore you can also use to find single characters inside. If you are not sure whether it is the full information about something. Okay, might be you have partial mobile number of somebody's. Okay, so you can write that mobile number and it will find, let's check this phone number, and you have partial information about that phone number. The actual phone number is this long. You know that this is the standard format of the mobile phone, but you have only idea about it starts with 789. You don't know the rest, and you don't know the rest, and it ends with this one. Okay, so it will find that person whose mobile number is like this one. So this is sometime is good if you know the vague information, not the exact information, and you want to search that particular person. You can use percentage sign and it will work, that also. Okay, but multiple characters, it found two occurrence, but with that the first implementation we have discussed in operator before in previous examples, but let's discuss this one in more details. In operator is basically allow you to specify a list of possible values in the where class. So we have used it before. It is used in where class. So let's check, like we have implies and where department id in. We are trying to find all those implies who belongs to department 3, 5, 6 and 7. Okay, let's say these are the departments, simplified version. So it will get all those implies. So imply id is in here. Okay, or we can give the values of like salary here in, and then you can give the list of salary. Okay, and it will find the salary and display the employee. So this is one way, like to fetch. In always work with the list of values. So whatever the value, if either is department id or salary or any other information you want to give, or manager's id, you can put it here, like where manager id is in 105, 106, 107, then it will get all those employees whose manager IDs that exist in the list. If you don't want, if you want to go opposite, you just add not. Okay, so now in this case it will give you all those which are not part of this list. So all those departments whose are not in this list, it will display all those employees here. And we can write the subqueries inside here, like department id in, and select department id from department. Okay, here it will give us error because it says sorry, my bad, spelling mistake. Okay, so here what it did is, like, it gave us complete it fetched this query, got all those departments first, all 10 of them, and this department exists in this basically subquery. So it will give you the list of all those 20 records, same as it was before, nothing changed here. Okay. But what int has contributed here is it just creates the list from this subquery and checks in whether it exists, then it will display you the actual implies. This is not the ideal case, but you get the jig. So here in subquery, let's say we are going to reduce the departments based on their budget. Okay, so the actual departments are 10, and here we can reduce where all those departments whose budget is greater than 300,000. Okay, so here it will give us only 6 departments whose budget is more than 300,000. The similar query we can write here with where clause. Okay, now what will happen is it's gonna give us all those employees whose department ID relies are inside that condition where the budget of those departments are more than 300,000. Okay, so it will give you only those employees who fulfill this requirement. So basically in you can use with another subquery, and here you can use order by first name. It will give you order, and you can write another where clause here, and sorry, so this is one, and another is where salary is more than 65,000. Okay, so it filtered down those records further. So we are getting all those departments whose budget is more than 300,000. So we got the list here, and then on the top of that, all salary of those employee must be more than 65,000. Then we are ordering by first name. Okay, so these are the records we end up getting those. Okay, so this is how you can use the complex query with the in, or if you can use other way like not in, so it will be other way around. Okay, so it will be less than 300,000. So only one employee satisfy that whose budget was less than 300,000, and but salary was somehow more than 65,000, order by first name. So only one person, David, is we got this one. Okay, and next one is between. So between is like we have used it before, where salary between 65,000 and 90,000. Okay? So we are getting all those employees whose salary is in between these two conditions. Okay, it can be dates or anything. Manager IDs more than in between 101 to 106, anything between. Okay, you can get those records like manager RD between 101 and 106. So it will give you all those employees who can satisfy this condition. So between is you can use on integers, or you can use either characters like in between first name John to last name William, sorry, Taylor. So it can get all those records here. Or the best way you will see is mostly between is used between the dates. Okay, so in this, like, we have hire date here. Okay, so hire date between this is and so we want to get all those between 1st of January to 31st of December 2023. All those implies whose hire date is in between. Okay, so all these 4 employees were hired in between 2023. Okay, so you can see that this is best scenario. Mostly reports or queries you write in for database, you have to add those dates. Okay, so always, like, there will be from the client side you pass queries like 2 dates through calendar control or something, and here this is the query you write to filter it down. Okay, so we have used this between before, simplified version, and the another one is the as one. Okay, so here we have let's say this one. So asterisk, we can use first name as f, or maybe f name, comma, and give us all those rest of the records. Okay, so here John, everything, but you see that the column name is changed. So this is like as, and you can use concatenation, like Python, and first name, last name as well. Okay. So you see here John and Doe, so it has concatenated all first name and last name, and the column name is missing, so you can use as name, for example. Okay, so complete name, and because it is with no space, so all names are muddled up, so you can use this another Python, and in between use like this one. Okay, so you have 2 Python in between space, so you have name as a John Doe, full name. Okay, sometimes there is requirements on the client side that we need full name or something like concatenated coming from the database. So this is how you can use it as John Doe, and also might be next thing is we are going to discuss the little bit complex concept. They're called join. Okay, so it's like a join. There are three, four different type of joins. I would say one is the actual join itself, which is full join. Basically, the idea is if you have two tables and you want to combine some rows based on some particular related columns. In our example, we have employee and department. So employee has this department ID there in our case. So each and every employee has department table. So primary foreign key. The similar, we can have few tables where some information does match on left side or right side of the table. Like first table is employee, second one is department. You can have might be 3, 4, 5 different tables. So any information you want to display from the first table, so it depends on the what sort of join you want to do. Inner join is basically it there are this main join and inner join, join left join is another one, right join is another one, full join, and the last one is cross join, but it's hardly used. But most of them are this left join and right join. Okay, inner join, left join. These are the most common one. What are they? Inner join is basically return records that have matching value in both tables. So both tables, if they have matching value, then it will return complete data set from both tables. So left join is it has matching value in both tables, okay, like from right side, but it will return the records for the left table. So we have left and right table. The left side we have like the main tables, like in this case is employee, and right side we have is department table. And if you use inner left join, it will display all data for employees, but it will match the record from the right table. And right join, we have all records from the right table but match the record from the left table. Okay, and the full join is when we have all matching, either doesn't matter whether it's left or right, so it will return all those records which is matched. Okay. So let's start with inner join, basically common records in both tables in our case. So we can use the inner join first. So these are joins, most commonly is inner join, and we are selecting everything from employee and inner join with the department. And when we use join, it will be on, okay, on which column you want these joins. So it will be on, and employee has department ID, this is join, and also department also has department ID. If we run this one, it gets all 20 records because all those employees has related department ID in the database. Okay, so nothing will change, but it is giving us all those records as well as the departments details is here. So department, this is from employee table, and the next one, all these columns are related to the actual department table. So it joins them together to show what you want to display. Okay, and because you are using asterisk, it will get everything, but here you can use or select only particular fields only. You can select like employee ID, first name, last name, email, only 3 columns here. Okay, and it will work. And also here you can notice that I wrote full table name and department name. Instead of, you can use alias as well here. Employee is E and D for department. So here you can use E and department D. And if you run this one, still it works. Okay, so basically to short the syntax, and in this way, like because if you want to write those columns name and also the columns from these departments, okay, it will be like long query to write full department dot department name. Instead of, you can write the short like D dot department name. What I mean is, like, if you want only in this whole query, you want only first name, last name, email, and department. Okay? In this case, you only want department name. Let's say, I don't think, see here, so department name, my mistake. So here it found the data because there are unique names, that's why you get the informations without any issue. But let's say if you want department ID, okay, here, then you will get, because system can't decide which department ID you are talking about, like whether it is employee dot department ID or department dot department ID. Okay, ambiguous. So you need to mention particular thing that is employee department ID. Okay. So now this is employee coming from employee table, this department ID. So one thing to notice, you can short these alias, you can add them like short name, and if there is ambiguous column, like similar column exists in both tables, so you definitely need to write the actual column with the table name. Okay, otherwise if they are unique column names, in this case like here, you don't need to write the actual table name with them, okay, with the dot. So this is called inner join, and it will give you the information like these are common records in both table. Okay, the next one is the left join. So it retrieves all records from the employee table and matching records from the department table. If no match is found, then null is returned for the department. Okay, let's try. And we have Sam and just left join. Still 20 records because we got column on the top. In this also you can see that our example has 20 records returned, okay, which is not ideal scenario because we should have the columns they are matching on the basis of the department ID, but so in a join I have tweaked the data a little bit. So let's check the data from the tables. So these are the employees, total five employees. Okay. And department. So there are 4 departments. Okay. Manager IDs doesn't matter, but just we are concerned with this one. So what happened is when we had this department initially we built, there was constraint. So all departments ID must be not null. Okay. But to give you the idea about these joins, okay, so what I did is I altered this employee department ID and drop null. So basically I'm allowing the null in the employee table. So now if you see here, before it was not allowed, their employee must be has department ID. So each and every employee must have a department ID. It was necessary, must, condition, constraint, but now I dropped it, okay, to give you the demonstration. So to start with the inner join, what's gonna happen is it will retrieve only records that have matching department ID values in both tables. Okay. So if we run this one, inner join, so only matching, all those matchings exist. We have total 5, but it gave us 4 because the department ID for one employee it was null. Okay, so strictly comparison here, inner join. So always if you want strict those columns which exist in both tables, you always use inner join. And then there is the left join. So left join it retrieves all records from the employee table and match records from the department table, but if no match is found, null is returned for the department. Okay, so simple, you can change to let's say left join. Okay, so if we run this one, you see ls brown, even the department is null, but still is giving us the actual value, okay, because it's left join. So it retrieves all the records from the employee table and matching records from the department table, but it returns only on the left side all those columns. Doesn't matter if it satisfies the condition here, but still it's going to return all those columns related to the actual left side table. Okay, now if we do, and also in this case you see that all ls is included in the result with null for department name, because they have no department ID assigned to it, and still it's showing because we are using left join. So all columns from the left side they will display. On the other hand, side right join, what it does is it retrieves all records from the department table and matching records from the employee table. If no match is found, null is returned from the employee. Okay, so if we use right join and here, so it's returning the information from the right hand side of the table, which is like department. Okay, so it will only display this marketing, but the records for employee is empty. Okay, on our left side, left join, it was giving us this column value, but marketing was getting null. Okay, here, but right join, it will give you the matching condition of left and then not matching columns from the right side. Okay, so you see all columns from the department table, but employee it's null. So this is right join. And then the next one is full join. So full join is like retrieve all records from both tables, doesn't matter. Now if you use like it's called full outer join, yes, here combination. So we have this satisfying condition which like it match with both departments, and it get all those 4 employees, and then on the left side it gets ls brown, and because it does not match with the department, so it give you the null here. And because on the right hand side the department table has marketing department which has no association or no associated employee, so it's gonna give you employee like nulls here. Okay, so full join is basically all sort of data, left, right, it will give you everything. Okay, then the last one is cross join. So cross join is basically each employee is paired with every department. So let's check then how it's like cross is Cartesian product, so multiplication, you will see first name law and department from employee, and E, and we can use here cross join department D. There is no condition here. Okay. So you will see, so 5 employee multiply by one marketing department, again multiply by another marketing department, another marketing department, and another marketing department. Okay, so we will have and one thing you notice is the null value is gone. So it's basically multiplication or Cartesian product it called. Okay, so you will have one side n number of rows, and the other side is m number of rows, so it's multiplication. So 5 rows multiplied by, if there are 5, so you will end up 25 records. But in our case we have 5 employees and 4 department. So 5 multiplied by 4, 20 iterations is gonna show you. Okay, so you can see that John has this department, marketing IT department, and the Sam next 5 records, again HR department, next 5 records, next 5 records. There should be some scenarios which this cross join can be useful, but it's hardly being used. Okay. So let's summarize what we learned here. So inner join is only matching records in both tables. Okay, and it does not include unmatching rows. And hello everyone, we are going to deep dive into another SQL operator which is quite powerful, and it is called union. Okay, union operator. Union, and why we need union is basically the purpose of the union is to combine 2 data set into one. And let's say we have 2-3 table and we want to combine into one table, one data set, then union is the best option. The practical example we can have is there is marketing department and they want to run or broadcast the email campaign to their customers and employees as well, because and employee can be customer. Okay, so there are duplicates information as well. So one way to do is to run 2 queries, one is on customer, the other one is employee, and then get the information together in separate tables or separate Excel sheets, and then merge together and then get rid of the duplicates. Okay, so it's a long process, cumbersome process to do or get the one data set. And Postgres or any database give built-in this union operator. Okay, to demonstrate it, I created the another extra table which is called customer table, and it has ID, first name, last name, email, phone number, and city, country, created at date. Okay, and let's check this table. The first one is employee table, which we've been using through the demonstration, and it has first name, last name, email, phone number, hire date. Second table is customers table, and it has first name, last name, email, phone number. But these two tables have this ls brown common. Okay, so you can see that the customer table has ls brown number 11. Okay, and employee table has ls brown at number 5. And if we use union, the first rule of the union is the query must have the same number of columns. That's the first rule. Okay, so number of columns here must be same, or and if there are 5 columns here, must be 5 column here as well on the customer. Okay, so the number of columns must tally to each other. That's the first rule. Let's say employee has hire date, and here you want to use email. That's the second rule. Okay, is the date and characters does not match, means this is date and this is the character. So second rule of union is that data types must match each other. Okay, if the first one is character column, the second one should be the character column as well to get merged and create one data set. So here if we write email, and then it has merged all those records, and one thing you can see is union has deleted or got rid of the duplicate information, like ls brown, this one. Okay, ls brown is supposed to be here as well on the number 16, but the union has removed that duplicate information or duplicate email addresses. So there are 3 things you have to notice, or you have to memorize or remember. Data type must be identical for each columns, and also the number of columns must match each other, and then the third thing is it will get rid of the duplicate row for you. Okay, so you don't have to do anything. And also the order matters. If for example the column 1 is of type string, then here column 1 on the customer must be type string, and also the column 2 is date, for example, and column 2 here must be date. Okay, regardless of their name doesn't matter, but the data types and should be, or number of columns must be identical. You can't swap, like here is string and date, and you can't do that like date and string. Okay, so order is also matter, one thing. So one thing, and like the order wise both should have the same. Okay, and here is email and here is email as well. And let's say you need first name and you need first name here too, and if you run, all are unique rows. And if you don't want to get rid of duplicates, all you have to do is use all here. Okay, so if you run that, you can see that ls brown is on number 16 and ls brown is number 5 as well here. Okay, so it has not removed the duplicates. So if you don't want to get rid of duplicates, you have option to add all, otherwise just use the normal union tab. Okay, and it will does the job. And And also performance wise, one thing is to remember that you can use order by here, order by first name, and it will work, and it will give you the all ascending orders information. But if data set is quite big one and you don't need an order, does not matter, better not to use this order by or where clause or something which is like the performance will be delayed. Okay, but it depends on your requirements or queries, what sort of information you want. And if the last thing you can remember is like the data types, what I said is must be the same. For example, here if hire date, if you include, it says the data type does not match. Okay, so what you can do is cast method, built-in method as text. Okay, you can use that one to convert all those into your related data types. So now email same data type, and this one has same data type. Okay, and you can see that the it says the column name, first name in the table does not match. Okay, so what I'm trying to show you is like you can cast the information in a way to merge together, like those columns which are not related to but you want to merge together. Okay, so here casting it, what it does is hire date is the date, so you cast it into text and you have this text, like you can have first name or something. Okay, and here it has the actual first name and then the date, hire date as well. It all depends on your requirements, what sort of data you want to merge together, but union will help you to achieve unique rows and also the combined data set from multiple queries. Yeah. So next thing we want to discuss is group by. So group by is a widely used operator, and it is used to get the actual sum, and is widely used with aggregated operators. Okay, functions like we have average, sum, count, those type of operators. uh, let's see, like we have implies. Okay, and usually we use like this one to calculate how many employees we have in our organization. So 35 employees are working in this organization, and if there is requirement that somehow if we need some sort of report. Okay, and imagine that you own the store and you want to see the total sales per product or the number of customers per city. Yeah? So that's where we have this group by come into the play. Okay, and the results are like compiled based on the actual we use this aggregated functions in the actual query, and then we use the group by clause at the end. Let me show you how it is done. uh, Here we have 35 implies, but if we want to group by let's say um, employee number. These are the employees. So we got this many employees, and what we want to do is we want to group by based on job titles. How many people are software developers and how many are project managers and HR something something. Okay, so we can count uh, based on job title, and if we run here it will give you all by actual not the actual table or value itself. Like the uniqueness operation should be or must be based on the column you want to group your actual information and want to calculate the actual reports itself. Okay, so in this case we were doing the employee, which does not make sense. Okay, we were doing like the actual table itself. You need the actual column which you want to use as a group. Okay, so in this case you can see that in some cases you are getting 2 3, in some cases 5, and these are the actual job titles. Okay, and if you add here then you will see, so HR generalist only 1 employee, coordinator 2 employees in the organization, HR specialist are 3 people, and software engineer 5 software engineers, 2 project managers. So this is how you start like counting based on your column, and then group based on that column, so you will get the actual total sum. Okay, and here you see that you can use as total or sum, any column name you want to give here. Okay, so it will give you the actual total now. Okay, one thing to note here is you can use either count, average, or sum, or any aggregated function to group those columns. And in this case, another one good example can be let's say we have employee and we want to inner join our department, and where I want to inner join is based on department ID. Okay, and here we can use alias END E department ID and D dot department ID, and if we run this one, so we are getting all those implies by using inner join and department ID. So now what we can do is we want to group by based on department. So we have this department which is like 3. Okay, here, and the actual department itself is finance. Now you want to count all those employees. You want to find out how many employees are in each department. So and group by department. So we have IT, this implies 15, finance 9, and HR 5, 10. So these are the people's, like each and every department they belong to. So we have total calculation based on the employee actual um, uh, data. Okay. One thing is you can't use where clause here, where for example all those employees whose salary is might be 65,000 something, and if you try to use this one, it will give you error. Okay, so always use, if you want to filter, use where clause before group by, and then use the actual group by itself. Okay, so here you will get 15, might be 95 something, I don't know. All those implies whose salary is 95 more than certain, you want to group by, so you got 13 rather than 15. Okay. And for group by you need the actual column name. You can use inner join as well, or you can have standalone. I want to discuss the where clause to use with this group by. And if you want to use where clause here, where if you want to use like all those departments more than, let's say, 10 or something. Okay, all those employees, like all those departments where more than 10 employees are working, if you want to use where clause, you will get error here. Voila. Okay, because where does not work, and also the order by is the last one. Okay? If you use like this one, so where order, this should be used right to the end. When you just filter down, everything is finished, then you can order your columns. So this order goes right to the end. If you are using this one, still you're getting where clause, because thing is where you can't use where with group after group grouping your data. So they have this new, which is having clause. Okay, so having instead of where, you always use having. And now only IT has more than 10 employees working in this department. There are, if you go on like 5 might be, and you'll get still 3 departments where there are more than 5 employees working on. So having is basically the replacement of where clause. When you group the elements together and get the data, then instead of where clause you should use having always. Okay, so having is the actual, basically is where, but particularly depends on the group by function. Okay? So, and you can use count, sum, average, anything here. Okay, and I gave you in here count example, but you can use average or sum or any aggregated functions by using the group by and having together, and then you can order. Okay, but if you want to sort the data or something, then you should do this where clause before using the group by. After group by, you can't use the where clause, you always use having. Okay, so before sorting or before, yeah, So next thing I want to discuss is exist and not exist. So these are widely used operator when you want to test the existence of a record by using the subquery. If something depends on the subquery, then you just check whether it exists or not. So it just give you, basically when subquery give you the results true false, based on that true false you can decide whether how many records on the main parent query will show or reflect. Okay. So let's start by the example is like we have employee. Okay, and we can see that there are 35 records in that one, but we want to see where it exists and select department ID from department. Okay, let's say, and it's not any conclusive query yet, but still it gives you 35, no change at all. Okay, and if here you decide that if this department ID is more than 4, okay, and still is not it will give you the results the way you wanted. Okay, where sorry, where ID is greater than 4. Here if you run the subquery, it's empty. Okay, so if you check the actual department itself, here you see that department IDs are only 4, they are not more than 4, so they can be equal but not more than 4. Okay, here you see, and because subquery is true, it will give all those 35 records. So basically anything which is true on the subquery, based on that condition you will get the actual data outside. Now if we narrow down a little bit more and we say that this is employee E, and here you do is department D, and now we can have employee dot department ID is equal to D dot department ID. Now in this case there are 35, and you will see it will give you 34 records. Okay, because one department which was like null, if you see it again, especially this employee table, you see here, this is the employee marketing department, the department ID is null. Okay, so when it use this strict comparison, employee ID and department ID, somehow this does not fulfill the requirements or the conditions, and it system eliminates this number 5 records, the number 5 or the row, this particular row from the system, and it will give you the only 34 records, and this is what this exist does. Another one is not exist. Okay, so now in this case we're gonna get only the record which was null. that department whose ID was null. Exist and sub and not exist. These are two things commonly used based on your subquery. If a subquery is filtering some data and information, and based on that information, if it returns true, false, or any particular, that's the information helps the main query to show the data based on the subquery, okay, decision. And after that, you still can use where clause, where like employee ID is greater than, for example, 20 something something, okay. And sorry, it's already where clause, and you can use and e dot employee ID, and here it will give you those employees whose ID is more than 20, okay? Hi, the next operator we're going to discuss is any operator, and it is another operator widely used in Postgres queries. Let's imagine, like, if you go in a restaurant and waiter gave you the list of available dessert, and one of three desserts can be cake, cookie, and donut, okay. And now if you ask, like, do you have any of these, ice cream, cake, or brownies, okay, and the answer is yes, because cake is available, okay. So you ask, like, in the menu is cake, donut, and cookie, but you're asking that you have any of these, ice cream, cake, or brownies, and the waiter said yes, the cake is available. So it means anything, at least three options you gave, the one is already available in the menu, and it's already available in the restaurant. So any means that at least the cake is available. So in Postgres, any operator works in a similar way. It checks if at least one value from the list matches your condition. So you have like three, but you ask two different options, but at least one was the same, like cake in your condition or your case. So it just is fulfill the requirements and give you the appropriate results. The so any operator in Postgres is quite powerful keyword that allow you to compare a value against multiple values stored in any array or subqueries. It helps you in writing more concise and readable queries. And let's check. For example, here is the existing table. You are much familiar with this one, employee table, and we can use any with where clause, and it will be a typical operator it can used is like equal sign with the greater than, less than, not equal to, okay. These are the common operators it can be used with. So in our case is where clause, and we can use like our department, let's say department ID is equal to any, or even you can write in capital, it doesn't matter, any. And then in Postgres you have to use array. We have 1, 2, and 3 departments. So let's say, like, we want to see all those employees which belongs to any of these departments, like either one or two. Okay, and here you can see that out of 35 records only it's showing 25. So those 25 has these departments. Either one, it belongs to, the employee belongs to either department 1 or the department 2. So this is how you can use is equal to and any, and then there is some condition you can use inside. Okay, any can be used in subqueries. Like here we have equal, and then we use the array which is fixed values, but instead of, you can use select queries, like select department ID from department where department ID in, we have used in operator before, so it will give you the same results. Okay, what have I done? I think this is extra. Yeah. Okay, so still you're getting the same results, but this is the flexibility now. Instead of hard coding, you can write some particular conditions based on your requirements. That's all those employees which either belongs to department 1 or department 2. List them, all of those employees. So this is how you can achieve the similar things with subqueries, and also by using the where clause to filter the results. Okay? And similar, you can use the here greater than might be 2. So all those employees whose department ID is more than 2, I need any of those. Okay, it can be the moment in our database only 1, 2 and 3 departments exist, but there is slight chance that there are might be 5, 6 or 10 different departments in a company, big one, large organizations. So in that case it will show more results related to department 3, 4, 5, 6 onwards, and you can use these filters by using where clause. And mostly this greater than, less than, does not equal to, these operators you can use in along with this any one. Okay? And the similar we can have instead of using subqueries, we can use array of like salary is greater than. Okay. So now you can find all those people whose salary is more, either not all, either like 45,000 let's say, and 55,000 or 65,000. Okay, now if we run this one, we are getting all 35 rows, all of them, because it fulfills either record, because minimum is 45, then 55 and 65. So it fulfills, the minimum is in this case I think is yes 62,000. So it lies here in between 55 and 65. So it fulfills one condition, and it shows all of those records in but you can change it. You can, if you want, like 75,000, and let's say we change to 85,000, and in our case is 65. Now it gave me 2 records less, so it got rid of 62,000. Okay, because 62,000 does not exist in this condition, and another record which was like I think it was 65, 62, and any other low value. I think 65 and 62. So it got rid of those and only showing because it's greater than, salary is greater than. Okay, so it got rid of 62 and 65,000 and giving me the rest of the actual employees. So this is how you can use any with equal sign, greater than sign, or less than sign, any condition, depends on your requirements. It's quite powerful, and it is widely used to filter the subsequent queries. And sometime there is we have learned the exist operator. So sometime the exist operator is better than any, because any, imagine if you write the subquery and you have million records. Okay, so this subquery can be cumbersome. It's like it can reduce the performance of the system unless you use so many different where clause and operator. The next operator we are going to use or discuss is all operator, and the it is widely used operator, and in Postgres is used in comparison operation. Okay, where the value is compared against all values returned by a subquery. It means that it must satisfy the condition for all values in the subquery results. And in simple term, we can say that the all operator is like a strict teacher who checks all the answers before making a decision. It is used in SQL queries when we compare a value against all values in a subquery or subset or in a list. Okay, and mostly how it's used is always used in where clause, and there are, like, you can use these comparison operators, greater than or less than, does not equal to. Okay, and or you can write does not equal to, like this one as well. Okay, so all these comparison operator, then all, this is how it is always. Okay, so comparison operator, and then immediately you have to write all. And the main query checks if in, like, let's say we want to see that if an employee salary is greater than our salaries in sales. Okay, or any department, we have department table, and it has IT, marketing, and finance. Okay, so we want to check whether HR department, let's say the HR department, we want to check if an employee's salary is greater than all salaries in HR. Okay, so the way to achieve that one is you select from employee, and then you use where clause, and salary is greater than, I would say, and all, and then subqueries. No, not like this. Select salary employee. It is inner join type of table. So we are using the same employee table. Okay, subquery also using the same employee table, but we are filtering down the data based on department ID is equal to 2. So you can see that it will check all employee salaries is greater than the salaries of all employees in HR department. Okay, so these are the actual employees whose salary is quite greater than, and they have quite huge salary. Okay, so one thing. Then another is we can if we want to use another way is let's say department. Okay, and what we want to do is the department table, and we want to list on all departments where all employees salaries are below than I would say like 65,000. Okay, so all list all departments where the all employees salary is below than 75,000. So let's check the department, and where class department ID is equal to all, and then select department ID from employee where salary is 60,000, I would say. So these are the departments whose employee salary is less than 60,000. Okay, or below than 60,000. So this is how you can use all operator, and the thing is it must fulfill all requirements. Okay, if either one of condition is untrue, the main query will not return any value at all. Okay, so at least it should satisfy all the conditions, then it will give you something in return. In any case, we learned previously, it out of 10 or might be 5 conditions, only one is true, then it will get those results. Okay, but here in all it is strict, like all conditions are value must be satisfied to give you the results based on your subquery. Okay, if subquery satisfy the actual condition. Okay, so we are finally through to the end of this tutorial, and the last one is the case expression. So the case expression is when you basically want to use if and else condition in a programming style inside this PostgreSQL, then you can use the case expression, and it lets you return different values based on your condition. Think it as a decision making tool in SQL. So you can use it when you want the results depends on your condition in your data. In real life example could be, imagine you have you run the company and you want to give bonuses to the employees, and if employee salary is more than 80,000, then give them 20% bonus. If it's between 50 or 60,000 to 80,000, then give them 10% bonus. Otherwise, give them 5% bonus. Okay, so you can use case in Postgres to apply these conditions in a query, and let's dive in by using similar employee table. Okay, so we have employee table and 35 brackets. The way we want to use, let's see, like suppose we have employee table and we want to calculate the percentage based on salary, okay, range. Then we can use few columns like employee ID, first name, salary from, okay, first name, my bad, so we have employee table with employee ID, first name and salary, and here we want to use the case, okay. So case starts with salary and you have to use the comma, and case for indentation purpose you can write to the next line, and salary is let's say greater than 80,000, I would say, then and add 20% bonus, and when again salary between, we can use between 50,000 and 80,000, then give them 10%, else 5%, okay, 5%, and the case ends with end, okay. This is the case. If you run that one, you will see that this is the next column it added and adds those percentage, the bonus, but this column does not make sense. We need to rename it. We can use alias as bonus percentage, yes, and now it is much more clear. Similar, like we can use another example. Let's say we have the department table. And that department table we want to classify these departments based on their budget, okay. You can see that 200,000 budget is marketing, and 150 IT, 70k is HR, and 85k is finance. So we can categorize based on those budgets, okay. So let's Sam, we can use department, might be name, I would say, and budget, and then case, case, and on the next line, when budget is greater than or equal to 100,000, then it is high budget. When budget is between 50,000 and 19,000, or in between 100,000, I would say 100,000, then is medium budget, else condition is low budget, okay. And similar to close this one with the end. So yeah, you can see that high budget departments and low budget departments. And similar, you can name the column to budget category, might be category. So this is how you can use case, when, then, else, between, and it ends here. Okay, and you need comma as well. This is one example, and also another example is you can use in order by. Let's say, suppose you have department table and budget, and we want to classify department based on their budget, but we want to sort the records dynamically. Okay, so this is one case. So we have salary in ascending order. Okay, you can do descending as well, but here order by, you can use the case as well. Case, and when salary is greater than 100,000, then it gives priority 1. So what we are trying to do is here is, usually you can sort the whole table based on one, like salary, but what we want to do is we want to give priority. All those who have more than 100,000 salary, they should be listed on first priority, and all those whose salary is between 75,000 to 100,000, we give them priority 2, and all others should get priority 3. Okay, so sorting within another sorting. So we sort the actual, but we want to give priority like batch wise priority. So this is how we are going to use the priority. If salary is between I would say 75,000 and 100,000, then give them priority 2, else everybody gets priority 3. And if you use here salary, sorry, it will be comma here. Okay, and now my bad, what have I done is end here, because everything needs to end as well, all statements. So here you can see that is ascending order, and all those first priority until this point, and in between 75 and 100,000 is only these two records, they are ascending. Okay, and then the rest 65 to 70,000 are priority 3. We can use this as a descending order. High salary until 100,000 first priority, then 75 to 100,000 is this one, second priority, and anything else is third priority. So this is how you can order, like use order and then the case as well. Okay, and you can order the actual column within columns, because when you use the outer one, it will apply throughout the whole column, but here you can sort the inner data by using the case expression. And this is the end of the video, and I will create another video to draw the complete e-commerce database from the scratch